I've thought long and hard about how to explain this one because it's a little bit different, and let me point out why it's different. It kind of comes in this word right here and the equation itself. Y-intercepts of the graph of that. And we get in such a habit of graphing things that are functions, and this one is not. This one is not a function at all. And by function I mean it doesn't pass the vertical line test. And that's implied in what it says. Y-intercepts. It's plural. There's more than one place where it crosses the y-axis. This graph does this. It's a sideways parabola. And so it doesn't have a singular output for an input of x. In other words, if I plug in an x into this equation, I'd get more than one y value. So solving it is going to be a little bit different. Now, if you were to type this in Desmos, it would graph it for you, and that's fantastic, but we don't have that luxury on this. So we could do something that's I'm not going to call it illegal, but it's going to help us really understand what this thing looks like and get to the point of what we're trying to get. If we want to know the distance between these y-intercepts, then we need to know what the y-intercepts are. So we need to know what that is, and then it's just as simple as subtracting them. So the whole point is finding the y-intercepts, but now we have to find what they are. So the illegal thing that I was going to do was to switch x and y and make that x-intercepts. However, I think it's best that we just keep it legal and we treat this problem the way it needs to be treated as a sideways parabola. Now, again, another alternative would be to switch these two, solve it for y, graph it in the calculator. That's fantastic. But I want to show you this because it drives a point home that's really neat. What's that coordinate right there? Now, the point is we don't know, but we know it's 0, comma something. And this point is also 0, comma something. We don't know what. 0, comma something, don't know, 0, comma something. If we knew them, we'll subtract them, like I've said. The distance between the y-intercepts, well, how do we find the y-intercepts? Plug in 0 for x. 0 plus 8 equals 2. Y plus 3 squared. Solve that for y. You got this. Obviously 0 plus 8 is 8. Divide that by 2 and you get 4. And we have this right here. How do we keep solving for y? We square root and we get 2 equals y plus 3. Now, it is plural. Therefore, we're going to have to get two y-intercepts. And here's how it happened. When we go from here to here, we square rooted. It makes it plus and minus. We will now subtract 3. So negative 3 plus and minus 2, and that is equal to y. One of the y-intercepts is negative 1. The other one is negative 5. At this point, if you're thinking a little bit ahead of me, then the answer is obvious. What's the distance between them? Well, the distance between those two is 4. Which means my picture is a little bit off, but that's okay. But like I said, there's the other alternative that I'm not going with, to where if none of this made sense and if your mind didn't go here, then you could have said, well, shoot, let's just switch this problem around and make it what we want. You can do this, switch x and y, solve it for y. I said I wasn't going to do this. I think I said that. And then type it in your calculator and figure it out. So again, if that made no sense, you can go this route. Oops, I'm in polar. Let's go to function. 2 and then x, whoops, 2 and then x plus 3 squared minus 8. Go to a standard window, zoom 6. There it is. You see it. These were y-intercepts. Now they're x-intercepts. -1, -5. The distance is 4. There we go.